Okay, guys, let's take a look at finding the area of the regular hexagon. We did these yesterday, given all the information right, so they gave us every single piece, and we just plugged in the formula. Today, we're going to solve these, and we may not have every part of the formula. So we're going to write the formula out. Remember, it's the side length times the apothem times the number of sides. So given this question, it says find the area of the hexagon if the perimeter is 60 centimeters. Well, if there's 6 sides and the perimeter is 60, that would mean that each side is 10. So the side length there is 10. And the number of sides, it's a hexagon, that's 6. So the only thing that we're missing here in our formula is the apothem. And unfortunately, they don't give that to us directly. So what I'll notice here is that if the whole side is length 10, then when I draw this triangle in here to solve for the apothem, the base of the triangle would basically be 5. This is where all that angle work we did yesterday is important. Each angle in a hexagon is 120 degrees, so when you split that in half, what you'll have left is a 60-degree angle here. So what we're really left with is a 30, 60, 90 triangle, where we're given the base. Now, if you remember your shortcuts, this is easy. If you remember your shortcuts, then the apothem is just going to be 5 times the square root of 3. But if you forgot that or you're not confident in that, you don't know how to do that, then an alternative would be, make sure you're in degree mode, but the alternative would be to say, okay, if I didn't know that length, let's call that A for the apothem. Well, relative to this angle, I've got opposite, I've got adjacent, so that's going to mean that the tangent of 60 is going to equal the apothem over 5. So now if you put 5 times the tangent of 60 in for the apothem, or 5 radical 3 in for the apothem, you're going to get the same answer. So now I do 1/2 times 10 times 6 times 5 times the square root of 3. And I'll get 259.81. This is centimeters, so it'll be centimeters squared. So that's my answer to question 1. Okay, guys, on this next example, I provided you with a little chart that sometimes helps guys, kind of summarize all the information. You don't have to answer all these questions. This is an organization tool. And sometimes it's helpful to look at this and just try to see what you have, what you know, and what you need to find. So, for instance, for this one, we're going to find the area. This is an equilateral triangle, and I know the formula for a triangle is 1/2 base times height, but we don't have the base or the height here. So we have to use our regular polygon formula to solve this one. So what are the number of sides here? Well, obviously there are 3 sides. Do we know the side lengths? We do not. Therefore, we can't find the perimeter. Do we know the apothem? We do know the apothem this time. It's 4. We don't know the area. That's what we're trying to find. And so let's look and see what we're trying to do here. So I wrote my formula up here. Area equals 1/2 SAN. I know the number of sides is 3. I know the apothem is 4. I've got that in my chart here. So what I'm really trying to find is the side length. I need the length of this entire side. Well, let me call this piece right here just X. Okay, so let's just call that part X. The side length would be 2 of those. So once I find what X equals, I need to double that to get the full side length. So let's see what I can do here. I know that if this is an equilateral triangle, that all of these are 60 degrees, 60 degrees. And when this bisects it, that makes that a 30... Oh my gosh, look at this, another 30, 60, 90 triangle. This is why when we did those shortcuts, guys, I said if you can remember the shortcut, it will save you a lot of time. I know that X is 4 times the square root of 3. I know that because I know my triangle shortcut. Just like in the first example, if you don't know that shortcut, I would suggest then that you just use trig and you get that value. Now what's you got to be careful about, though, is that 4 times the square root of 3 is not the length of the entire side. X is only half the length of this side. So what we need to do is double that. So the side length is actually going to be 2 times 4, or 8 times the square root of 3. And there's 3 of those for the perimeter, so that would be 24 times the square root of 3. And so let's find the area, guys. If the entire side length is 8 times the square root of 3, then we'll put that in our calculator. And when we put that in our calculator, we end up getting 83.138. So that's 83.138. We don't have any units here, so we'll just leave that alone. We could say units squared if we wanted to, 83.138. What that means by the area of one triangle is one triangle like this. So that organizational tool, sometimes you get one triangle. Obviously, it would be a third of our number, so it would be 27.712. So, sometimes you could use this box if they give you some of this information to kind of work backwards and solve area. But you don't have to do that. Once you get 83.138, you are finished. All right, on to the next one. Hey, it's a square. We love squares. That's just base times height, except wait, we don't have the base, we don't have the height. A square is a type of regular polygon, so I can use my regular polygon formula to solve this. I don't know the side length, okay? I don't know the apothem. Remember, 6 is a radius here, not the apothem. But I do know the number of sides. So unfortunately on this one, the only thing I have here is the number of sides. I don't have anything else. Now, when I think about this being a square, each of these being 90 degrees, that means that this is going to be a 45, 45, 90 triangle. So this is helpful for 2 reasons. First of all, I know if this 45, 45, 90, that those are congruent. So once I find one of those sides, I've already found the other one. And so you could either remember your shortcuts, in which case this would be 6 divided by the square root of 2, or you could use trig again. So maybe we would call this x, and so relative to this angle here, we've got the adjacent side and the hypotenuse, so we could say the cosine of 45 equals the adjacent side, which we're calling x, over 6, or 6 times the cosine of 45. That equals x. Now remember, it takes 2 of those. It takes 2 of those to go the entire length of this. So the side length is actually 2 times that, or 12 times the cosine of 45. And the apothem then would just be a single x, 6 times the cosine of 45. So as we're using this now, I can say this is 1/2 times the side length, which is 12 cosine of 45, times the apothem, which is 6 times the cosine of 45, times the number of sides, which is 4. And when I work all that out, I end up getting simply 72. I don't have units here, so that would be 72 units squared. If you used 6 radical 2, or 6 divided by radical 2, that would be the apothem, and then double that would be 12 divided by radical 2, so you could do that as well. So there's a few ways to solve a square. Let's move on to the pentagon, which is the most unique one, and one in which we will have to use trig. We don't have any of our 45, 45, 90, or 30, 60, 90 shortcuts to help us out this time, so we'll have to use trig on the next one. So make sure, even if you've watched up to this point, you must watch the next one, because this is probably the one that is the most crucial to figuring out octagons, nonagons, and any other agons that you have that aren't hexagons, squares, or equilateral triangles. Okay, so here we are. The number of sides is 5. The length of each side is 8. This is good, right? Because I have 1/2 times the side length times the apothem times the number of sides. Well, the side length is 8. The number of sides is 5. The only thing I'm missing here is the apothem. That's the only thing that I'm missing. So in this one, they haven't really drawn it in for us. So let's draw our apothem in. Remember, that's at a 90-degree angle. from the middle. I'll call that little a, lowercase a, for apothem, and I'll draw this triangle in. Now, if the entire side length is 8, if all of these side lengths are 8, then half that, if I'm just doing half that, that triangle would have a base of 4. Similarly, I have to figure out what these angles are. Well, in a pentagon, these are 108 degree angles. You can use the old polygon sum conjecture to do that, or you could do 360 divided by 5 and then divide that by 2, and you would get 36 degrees here on the inside. So you would either get 36 degrees there, or you could get 54 degrees here. I think it's easier to get to 54 degrees, honestly. So now that I look at this, I'm going to say this. Okay, relative to this angle, I have the opposite side and the adjacent side. So opposite and adjacent is going to mean I'm going to use the tangent. So I'm going to say the tangent of 54 degrees is going to equal the apothem over 4. Now, if you use 36, if you use this 36 degree angle here, you would have 4 over a because your opposite and adjacent would be different. Either way, I multiply both sides by 4 here, and I get 4 times the tangent of 54 equals the apothem. So go ahead and write that in, 4 times the tangent of 54. So now what we have here is we have our equation written out. Now, I caution you, when you put this in your calculator, make sure that you close the parenthesis behind 54. Otherwise, it's going to do the tangent of whatever 54 times 5 is 270, right? It's going to do the tangent of 270 degrees, and it might give you an error or it might give you the wrong answer. So make sure when you put this in your calculator that you close the parenthesis behind the tangent of 54, or you could just move, because you multiply in any order, you could just multiply the beginning of this by 5, right? So 0.5 times 8 times 4 times 5 times the tangent of 54, and we work all that out. We end up getting an area of 110.11. They did give us units this time, so it'd be centimeters squared. All right, guys, there's more examples in your book. There are some examples online, and hopefully this video was a primary source for instruction where you kind of understand what's going on now. Please contact me if you have trouble with this, and have a great day.